The timer itself that we will be having is going to be set up in our game mode, so we can use our game mode as a common point to measure the 7 seconds, and we can, let's say, call an event dispatcher to notify our ghosts that they have to change their modes. So that is something that we can do. So inside our Pacman game mode, we can go ahead and add an event dispatcher. There are many ways to do it, but this is one of the ways to do it. Alright, so what you can do is you can go ahead and add an event dispatcher, and you can call it on scatter complete. So this will be after 7 seconds. Now if you know the Pacman ghost logic a little bit better, maybe you can do that. Otherwise, this is how we'll be doing that. Now one thing I want to do is I want to have some sort of a start game function. So this is when we'll start our timer. So over here we can go ahead and set a timer by function name, and what we'll do is we'll just do something really simple. So we are going to have a custom event, and we'll call this call on scatter complete. Alright, or you can call it complete scatter. So I can go ahead and call it over here, and now what I can do is I can copy this custom event name, copy this, go ahead and paste it, and we can just hard code this to 7 seconds, or we can promote this to a variable and call it scatter mode duration. Okay, so now theoretically we should be able to bind this event in our ghost. So what this timer does is after 7 seconds it's going to call this function. So as you see, after 7 seconds it's going to call this function. But what we have to do is in our ghost, now remember this is common functionality for all the ghosts, so we are going to do it in BP ghost itself. We'll not be using the derived classes. What we'll do is on begin play itself, we are going to bind the event over here. So we can first of all get the game mode. So we'll get the game mode and we can go ahead and cast it to Pacman game mode. So we can also store the reference in case we need it for something in the future. So we can promote the game mode to a variable, and we can call this one game mode ref. And generally I like to put this entire thing in a function. Now the game mode will be constructed before the character, but there may be some entities which will be constructed after the character, so you can use polling for that. So you can like set a looping timer to continuously check for the validity of the references, but nonetheless for our case we don't need any of that. I'll just go ahead and collapse this to a function and call this one get references. So any logic that is there, we are going to be doing it over here. And since this is pretty straightforward, we directly end the references part. So we'll get the game mode ref here, and we are going to bind event on scatter complete. Now for the event itself, what we can do is we can go ahead and create a custom event, and we can call it change movement mode. Change movement mode. And another thing is that over here, rather than on scatter complete, we should rather call it something like change movement mode or something. So that's probably a way better description. So we'll call this one change movement mode. So this will be a way to globally change the mode, and we'll take a parameter over here. We'll call this one on scatter complete itself. We'll not change that. And over here we'll take one parameter. So go ahead and add an input over here, and we'll call this one whatever the movement mode was. So I think it was called ghost mode. Alright, and we'll call this one new mode. Alright, we'll go ahead and compile this again. So it's showing some errors, but I'm pretty sure it is all fine. So if I go to file, refresh all nodes, this should be fine. If you encounter any such issues, just do that. It's going to fix things. Alright, now Once this is done, we should be able to switch from scatter mode to chase mode. So if I go ahead and check this out, so as you see, we can switch. If we have any logic here, we can go ahead and add it. Now in your ghost, again we can go ahead and bind this event. So what we can do is we can go ahead and create a custom event of this type, and then we can go ahead and call this one on movement mode change. Alright. So this event is going to be responsible. One more thing that we'll be making use of is runtime polymorphism. So I'll just show you what that means. So basically we'll be using function overriding. So now we have a function called on movement mode change in Ghost, but we also want to call it on Blinky, Pinky, Inky or whatever, because that's really what our ultimate objective is. It needs to be called on the Ghost, not on the parent class. There is actually going to be no instance of BP Ghost in the level. So we'll be making use of runtime polymorphism. So what we can do is just to show you how it works. So I'll call this in parent, and over here if you actually notice, if you right click and if you type in on, I'm not sure what I called it, so it's on movement mode change. So on movement mode change, as you see, we actually get this. So if I say event on movement mode changed, so I believe this one is in the character movement component. So just to avoid any conflicts, let's call it on mode change. That should be enough, just to avoid any naming conflicts in case that happens. Shouldn't, but in case that happens, we can avoid that. So what I can do is I can say event on mode change. Now if I go ahead and print, let's say I can say in child, and if I right click and add a call to the parent function, so now it's going to call the logic which was in BP Ghost, and then it's going to call the logic here. If you're familiar with Java, it's equivalent to super. If you're familiar with C++, it's equivalent of calling it on the parent class itself using the scope resolution operator. So I guess just to test it, we can go ahead and reduce the time to, let's say, about 1 or 2 seconds, and I'll just call start game. Alright, go ahead and press play. Alright, so as you can see, nothing really happens. So I call start game, so call on scatter complete. Alright, just make sure the game mode is correct as well. So it is in Pacman game mode. The problem seems to be that we don't actually have a ghost instance. So we'll actually put in Blinky into the world. So we'll drag Blinky because Blinky is where we had the logic. Now if I go ahead and press play, so as you see, you get in parent and you get in child. So this is the way you can actually utilize inheritance. So if you have some logic in the parent, you can perform that. And then in the child, you can call the parent. Basically, the event is actually going to be called here, not in the parent. But when you call the parent, it's going to execute this logic as well. So that's basically going to solve your problems regarding reusability of your logic. So any common logic that's there will go in BP Ghost. Let's go ahead and write the logic now. Alright, so now that we have the new mode, we can just perform a simple switch over here. So based on the mode, so in frightened mode, it's going to be a common logic for the ghost as well as Blinky, Inky and all the other characters. So this one is going to be fairly straightforward. We'll be using a node called AI move to. So although this sounds very fancy, it's fairly simple. It's just going to get a random point in the navigation radius and it's going to just go over there. So move randomly. So what we'll do is that's very easy to set up. First, let's set up the navigation. So under your place actors panel, just search for nav mesh bounds volume. So what this is basically going to do is it's going to define the area of navigation. So if you go to show, navigation, you can actually see. So our AI will be able to navigate in this area. So a very simple thing that we can do is we can scale it up, or we can increase the box shape. I like to do it over here. So if you just search for it, so not sure where it went. So it should be somewhere over here, the size. Oops, I'm not in the details panel. So now if I increase, I believe around 3500 should be perfect. So that seems about right. So it's exceeding a bit, but it's fine. So 3500 by 3500. So it's a little big, but not an issue. And let's say the height I set it to 400. So it can't get on top, but anyways, I'll just set it to 300 just to be safe. Alright. So this is the area where it can navigate. But the problem right now is that the characters here are moving. So what's the problem with that, you may ask? The problem is that every time the character moves, the navigation actually has to update. But that doesn't happen because if you look at the top left here, it says the mode is default, that is static. What static means is, let's say I've placed a character here. For the entire duration of the game, it's going to assume that this area is blocked. So it's going to assume that our AI cannot navigate through this area. But that may not be the case because Pacman can move. So during the game, maybe the Pacman moves here. But the game still thinks that this area right here, where I'm pointing right now, is still blocked. To prevent that, we can go ahead and head into our project settings and we can change the runtime mode for the navigation. So I believe it's called runtime mode, or it's called whatever. If I search over here, I should get it. It should be under navigation or whatever. So runtime generation, dynamic modifiers only. Now you can do dynamic if you're really lazy, but that really cuts down on your FPS. So I don't recommend you do dynamic modifier, fully dynamic. It's better you do dynamic modifiers only. Now inside Pacman and whichever character that moves, you can do a very simple setup. Just select everything first of all, and there is a property called can affect navigation. Just go ahead and disable that. Then what you do is you add something called a nav modifier, and over here if you select the nav modifier, everything should be set up correctly. But one thing that you will want to do is, rather, okay, we can actually see the differences over here. So all these things seem fine. So basically now whenever we are going to move, the navigation is actually going to get affected. Now if you were to notice, so I'll actually simulate rather than play. So if I simulate over here, so as you see, it is calculating the navigation every time I move Pacman. Now what you can do is, in the nav modifier, you can go ahead and just set this distance to 0. So that small space around Pacman is going to go, and it's going to be the mesh itself. So that's exactly what we need. We don't really require any safe area checks. We'll handle that in our code if required. Now in our AI move to, so in frightened, we'll basically go to a random point. So this is very simple. So the simplest way to do this is, there is actually a function called get random location in navigable radius, or you also have get random reachable point in radius. So these are the two things which you can use. So if you call this function with the origin as Pacman's location, or rather the ghost location. So if I type in get actor location, so we'll get the location of the ghost. That's going to be the origin. And the radius, let's just set it to 3500. So of course it's going to take it from the navigation data, so not to worry too much about the reachability. And we'll get the random location, and that will be our destination. Alright. And the pawn is going to be self, because we are the ones who are moving. And target actor is not really required. Acceptance radius, let it be 5 for now. So temporarily for ghost, I'm going to just put the mannequin mesh so that we can just see something moving. So under mesh, I'm just going to select let's say SK Manny. So I'll just select this. Of course, this is just for testing purposes. So I'll just move him down and I'll go ahead and rotate him. So this is just for testing purposes. This is not meant to be there in the final one. Alright. So go ahead and add this. So I'll drag in Blinky, for example. So one thing what we can do to test this out is we can go ahead and change the default movement mode to be frightened, or what we can do is in here we can just change this to frightened for testing. So now if I were to go ahead and hit simulate, so after a second you should see that the ghost starts navigating to a random point. So until he is in frightened mode, we have to do this. So this is very simple. So we are going to chase mode. This is not going to change. Make sure you put that back. So whether it succeeds or fails, at the end, if he is still in frightened mode, we want to come back over here. So that's basically what we want to do. So if it's a success or it's a failure, what we can do is if we are still in frightened mode, we can go ahead and call this on mode change function. So on mode change, and if he is in frightened, we can go ahead and call frightened again. What this will do is this will basically come back over here. So this is how we'll base the logic. So if he's frightened, we'll just go to a random location. Whether it succeeds or fails, we are going to again go to a random location if we are still in frightened mode. So if I go ahead and hit simulate, so nothing is going to happen obviously. But if we go ahead and run our testing code once again by changing this to frightened. So as you see, so it's going to start moving. So as you see, it will keep moving randomly. Of course, it does not care whether something is there in its way or no. And of course, this is not going to be 100% like original Pacman, because it's probably going to take the shortest path here rather than looking at stuff like squares. Pacman works based on squares, so it's not going to see that. It's just going to go diagonally and stuff like this, but doesn't matter. For the scope of this is probably better. So as you see, we had a hiccup, but again the ghost started moving.